Okay, so our essential question, how do we solve a system of equations using graphing? A system of linear equations, or I can shorten it to linear system, is a set of two or more linear equations with the same variables. Okay? So we're going to be working with two equations and two variables. When you get to algebra 2, we step it up a bit and you start looking at three equations with three variables. Okay? But we're just looking at the two equations with two variables right now. So this is an example of what a linear system looks like. Okay? So right here, I have two equations, and there are two variables in each equation, and they are the same two variables in both equations. Okay? So that is a linear system. The solution of a linear system. For a two-variable system, the solution is an ordered pair which satisfies all equations in the system. So for the system that we have up here on top, the solution to this system would be the point 3, 2. You can find that by graphing the two lines and find the point where the two lines intersect. So just so you know what I mean by it holds true for both equations, that means if I plug the point into the equations, it's going to work in both. So let me show you that real quick. So if I take the first one, x plus 2y equals 7. I plug in my x number. So the 3 goes into the x spot. And then the y number is the 2. So 3 plus 2 times 2 is 4. I'm checking to see that it equals 7. 3 plus 4 is 7. 7 does equal 7, so that worked. Now you check the other equation. So the other equation was 3x minus 2y equals 5. So you're going to plug that number in. So 3 times 3 minus 2 times 2 equals 5. So 3 times 3 is 9. 2 times 2 is 4. We're checking to see that it equals 5. 9 minus 4 is 5. That does equal 5. So it did work in both equations. So that's what I mean by working in both equations. So we're going to graph and solve the following system of equations. So we have negative x plus y equals 5 and 2x plus y equals 8. So for both cases, before you do the graphing, you have to rewrite the equations so you can get the slope and the y-intercept. It helps with the graphing, makes the graphing go a little quicker. So the first one, negative x plus y equals 5. So we're going to add x to both sides. Y equals x plus 5. Okay, so we have a y-intercept of 0, 5, and our slope of 1. Okay, so we're going to use that to graph that line. I'm going to color code it. So take the other equation, 2x plus y equals 8, minus the 2x from both sides. So y equals negative 2x plus 8. So my y-intercept, 0, 8. Slope, m equals negative 2. So we're going to go ahead and do this one first. So y-intercept is 0, 5. I need to scale my axes first. So make sure when you do your graphs, you scale your axes all the way around. So now I can graph y-intercept 0, 5. 0, 5 goes right there. My slope is 1, so that's up 1 over 1 to the right, up to the right. Now, it's really important that when you are graphing or solving a system of equations with graphing, that you put as many dots as will fit on your graph. That way you make sure your line goes through all the dots it's supposed to go through, and it's easier to find the point of intersection. So let me draw in my line. So then this one next, 0, 8, it's right there. Slope is negative 2. Negative means you go down 2 to the right 1. Ooh, we've already found our point of intersection. Down 2 to the right 1, down 2 to the right 1. And then draw on your line. Once you have both lines on the graph, identify the solution. The solution is the ordered pair represented by where those two lines cross. That right there is my solution. So then you write what that ordered pair is. So that's 1, 6. That's the solution. Once you get your solution, the next thing you have to do is check to make sure that it works. So we're going to check our solution. When you do the check, you need to go back and check in the original equations, always in the original equations. You cannot use any of the equation steps down here. It has to be in the original. So we have negative x plus y equals 5 is my first equation. My second equation was 2x plus y equals 8. And we're going to check. Not only do you have to check in the original, you have to check in both of them. Okay? So plug in the x value. So there's my x value. So negative 1 plus the y value. Here's my y value. 6 equals 5. Negative 1 plus 6 is 5. So it works in that one. Now we got to make sure that it works in the other one. 2 times x. X is 1. Y is 6. 2 times 1 is 2. 2 plus 6 is 8. 8 equals 8. Yes, it does. So it does work in both equations. That is my solution. This is just kind of a how do you solve using graphing? How do you solve a system using graphing? It's very short. You could probably shorten it even more. First, graph both equations on the same coordinate plane. Okay, so you're going to graph both lines. One graph, 2 lines. Second, you're going to estimate the coordinates of the point of intersection. Okay, sometimes it's very obvious if you have a nice, accurate, scaled graph using a ruler, so everything is nice and neat. You can find that point. It's in a nice spot, okay, a corner. It's easy to identify. Sometimes it's not so easy to identify. It might be a fraction. So instead of being on a corner, it's off the corner a little bit. So it's like 0.56 instead of 1.6, for example. Okay, so that's why it says estimate. And then the third thing you want to do is check the coordinates algebraically by substituting into the original linear system. So basically, you take your answer, plug it into both equations, both of the original equations, to see if they work. If they work in both, you did it right. If one of them doesn't work, then you want to fix that equation. Try to check that graph. Maybe you did the slope backwards, or you put the y-intercept on a different axis than it was supposed to be on. Okay. So there are some things that you can go back and check. Okay, so here's a practice problem. Go ahead and work this out, and then we will check it next class.